Here is the answer for day 4, problem 1. Graph on a coordinate grid. We have the expression y equals 3 to the x. This is called an exponential function. It's going to make a predictable shape on the grid, but until you've done a few of these, you're not going to know what shape it is. An exponential function displays growth when the base is positive and displays decay when the base is negative. In this case, the base is positive 3. I am expecting a graph that shows growth with this general shape to it. I didn't put a grid on here already, so let's do that first. A y-axis and an x-axis. And let's put some tick marks on the axis lines. The reason I didn't provide the grid ahead of time is because I wanted you to put some thought into what kind of marks you would need on the axis lines. For example, if you use a 2 where x is, which is a pretty small and easy number to use, what's the value of y? What would be 3 to the second power? That's a 9. So on the y-axis, we would need to get at least to a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If we were to use 3 for x, which again is a pretty small number, y would equal 3 to the third, which is 27. In that case, we would have to have 27 marks going up the y-axis. And I don't know if we have enough space in the box to do that. Even though you're allowed to use any number you want for x, in the amount of space we have, we're limited in what we can choose. On the x-axis, I'm going to make at least 2 marks. I can make more, but as x increases, y increases very quickly and will be off the top of the grid. Let's put some marks in the negative direction as well. And we'll put a few marks going down, but we're going to find out in a bit we're not going to need those. To graph this function, you use the same technique that's worked all year long. Make an xy table and make y's choices in the table. The type of function you're graphing affects the kind of choices that you make. For instance, when you graph parabolas, one of your choices must be the vertex. Or when you graph lines, one of your choices has to get you the y-intercept. For our exponential function, let's choose small, easy-to-use numbers to use for x. One of them I'm going to use is 0. Y equals 3 to the 0. That turns out to be 1, and that's called the y-intercept. This graph is crossing the y-axis at 1. Another number I'll choose for x is positive 1. Y equals 3 to the 1. That turns out to be 3. So another dot on the graph is 1, 3. Another number that's easy to use for x is 2. Y equals 3 to the second power, which is 9. And let's find 2, 9. We already discussed that if you use 3 for x, that y would be 27, and you'd be way up here off the top of your paper. Let's not ignore negative numbers, so use negative 1 for x. Y equals 3 to the negative 1 power. A negative power is a reciprocal, so this is 1 over 3. Left 1, up a third. 1/3 is not up to a height of 1. It's 1/3 of the way to the first mark. And let's choose negative 2. Y equals 3 to the negative 2. That makes the fraction 1/9. So left 2 and up a 9th. That is a really tiny fraction. We're barely above the x-axis. Now we can draw in our shape. Start along the x-axis, which is an asymptote to our graph, and swing up through the dots. Arrowheads on the end to show it keeps going. So here is the general shape for an exponential function that has growth. Now problem 2. Here's another exponential function. The difference is that the base is a fraction. This involves decay. As you move to the right, the graph will be coming downhill. Let's make a grid. and put some marks on the x-axis and y-axis. I'll put some marks going down, but we're not going to need them. To make the graph, let's start with an xy table and choose y's numbers for x. Let's choose 0, because 1/2 to the 0 makes 1. One of the dots is 0, 1, and that's called the y-intercept. Let's choose a 1 for x. Y equals 1/2 to the first power. That's 1/2. So write 1 up 1/2. 1/2 is not all the way to the first mark, only halfway up to the first mark. Let's choose 2 for x. Y equals 1/2 to the second power. That's 1/4. So over 2 and up 1/4. 1/4 is just a little bit above the x-axis. Let's not ignore negative x values. Let's use -1 for x. Y equals 1/2 to the -1 power. A -1 power means a reciprocal. So you get 2 over 1, or just 2. So when x is -1, y is at a height of 2. Let's choose -2 for x. Y equals 1/2 to the -2. A negative exponent is a reciprocal. So when you flip 1/2 over, you get 2 to the 2, which makes 4. So -2, 4. And we might find one more. Let's use -3 for x. Y equals 1/2 to the -3. That makes 8. So left 3 up 8. Now we can draw in our curve. As you travel to the right, it will get closer and closer to the x-axis without actually touching it. The x-axis is an asymptote line.